All right, here we go. So solving equations is 9.1 for us. All right, so an equation is a statement that two algebraic expressions are equal. An example, just a simple example of that is x plus 5 equal to 7. And a solution for that equation, what we will be trying to solve for, is a value that will make the equation true. So whenever you're trying to solve for an equation, you should be asking yourself, when is this statement true? Or in this case, when is x plus 5 equal to 7? And your answer will be when x is equal to 2. And the way you would check your solution is by plugging it back into your equation for x, or for the variable that you're dealing with, and 2 plus 5 is equal to 7. While you guys are writing that, just a reminder, while I'm going through the lecture, if you want me to repeat something, or if I move the screen too fast, you want me to scroll back down or something like that, feel free to unmute yourself and interject. I may not see your hand being raised through the chat because my screen is on this note page and it's not on Blackboard Collaborate. So always feel free to unmute yourself and just speak if you want me to repeat something, or if you want me to show the back of the screen, or show something that I've already left. Just let me know. All right, so we will be solving these equations by using what I call opposite operations. They're operations that undo what the other ones. Because your goal, if you look right here, our goal is to get x by itself on one side of the equation. So we need to undo what's being done to x so that x can be alone on one side of the equation. So addition and subtraction are opposite operations of each other. Multiplication and division are opposite operations of each other. They undo what the other one does. Also, our equation is split up into two sides, and it's split up by the equal sign. And so the reason why I point that out is that you have the left side of your equal sign, the right side of your equal sign, or in other words, left side of your equation, right side of your equation. So notice I have here x plus 5 equal to 7. I want to undo the addition of 5 to the x, so I will be looking to subtract 5. But if I subtract 5 from one side of the equation, I have to subtract 5 from the other side as well. So that on the left side, 5 cancels, leave me with just x on the left side. But on the right side, 7 minus 5 is 2, which is our solution. And once again, you can check your solution by plugging it into the original equation to see if it actually gives you the true statement. And so 2 plus 5 is equal to 7. And that's the foundation of solving equations. You will be looking to undo what's being done to the x so that you can get it alone on one side of the equation. All right, so let's walk through these one-step equations to solve. The first one is y minus 10 equal to 20. So just to resize the opposite operation thought process, if I have y minus 10 equal to 20, I want to add 10 to both sides of my equation. 10's cancel on the left, leaving me with y. On the right, 20 plus 10 is 30. Next one is 5a equal to 13. So that's 5 times a. So if I want to undo the multiplication of 5, I will divide by 5. 5 cancels on the left, leaving me with just a. 13 divided by 5 is my answer. Since 5 can't divide into 13 evenly, I can leave it as a fraction. If I had a scenario like this, let's say if I had 4 over 6, I would be expected to reduce the fraction. So 4 is 2 times 2, 6 is 2 times 3, those 2's cancel, and leave me with 2 over 3. So I am expected to do this. I do not have to turn a 13 over 5 to a decimal or a mixed number. 13 over 5 is fine. And going back to the 4 over 6, leaving it as 2/3 is fine. So I don't have to convert that to a decimal. So the last one like this, x divided by 9. I would multiply both sides by 9 because I'm trying to get rid of the division. And x would be equal to 99. Any questions on anything so far? All right, adding a little more to it, we have 2x plus 1 equal to 7. The most efficient way of taking care of this type of problem or starting this type of problem is to first move 1. We could divide by 2 first, but we have to divide everything by 2, and that will create fractions for us. So we don't want that if we don't have to deal with that. So the first thing we should do is subtract 1 from both sides. 1's cancel, leaving me with 2x. And 7 minus 1 is equal to 6. And divide by 2. X is equal to 3. Remember, whatever we do to one side of the equation, one side of the equal sign, you do to both. So keep it with that same thought process. All right. So the next one, we have 5x plus 9 equal to 23 minus 2x. And like I said before, keep in mind that I can't see you guys. So if I'm moving too fast or anything like that, you can always say, hold on 1 second, let me get this or whatever. You know, if we were in the classroom, I could see you, but of course I can't see that. So we have here 5x plus 9 equal to 23 minus 2x. So the first thing we should note is that we have x in two different places in our equation, and they're on different sides of our equation. So your goal should be to get all of your terms with x on one side of the equation, all of the terms without x on the other. So notice we have four different terms here: 5x, 9, 23, and -2. It does not matter which one you move first or which side you take it to. As long as you do everything correctly, you'll still get the same answer. So I'm going to take 2x to the left side. So that means I will add 2x to both sides. 2x on the right cancels. On the left, I have 5 plus 2x, which is 7x, plus 9. Remember, we're only adding like terms, so the 5x and the 2x add together. The 9 is not affected, so 7x plus 9 equal to 23. Now I need to subtract 9 from both sides. 9's cancel left. 23 minus 9 is 14, so I'm looking at 7x equal to 14. Divided by 7. X is equal to 2. All right, let's look at the next one. All right, so we have 8x minus 3 times the quantity of 4x minus 5 equal to negative 2x plus 6. So the first thing we want to do is get rid of this parentheses because we need access to this x. So we'll distribute negative 3 into the parentheses. So that'll be 8x minus 12x plus 15 equal to negative 2x plus 6. So negative 3 times 4x is negative 12. Negative 3 times negative 5 is 15. So from there, we'll combine the like terms. 8x minus 12x will give me negative x plus 15 equal to negative 2x plus 6. All right, so now we have the scenario as we had before, in which we have our x terms in two different places. So last time I took my x term to the left, I'll take it to the right this time. It doesn't matter. Just trying to show you that it doesn't matter as long as you do it correctly. So I'll add 4x to both sides. 4x cancels on the left. That leaves you with 15. Negative 2x plus 4x gives you a positive 2x. And plus 6 is still there. Now I need to subtract 6 from both sides. 6 is canceled on the right. 15 minus 6 is 9. Finish it off by dividing by 2. X is equal to 9 over 2. Any questions? Any questions? All right. All right. So looking at the next one, we have 3x over 4 minus 6 equal to x over 3 minus 1. So we have two options here. Either we can solve the equation the way it is with the fractions involved, or we can do what we call clearing out your fractions. So going through the clearing out the fractions process. First thing we want to do is find the LCD. And your LCD is the smallest number that each denominator can divide into evenly. So we're talking about the 4 and the 3. So we want the smallest that 4 and 3 can divide into, not what can divide into them, but what they can divide into, and that would be 12. We're looking for the smallest number that each denominator can divide into. All right. Step 2 is we're going to multiply each numerator by the LCD. So notice that we're talking about the numerator, multiplying each numerator by the LCD. We're not multiplying top and bottom. We're multiplying across the equation. So we're going to multiply each numerator by the LCD. So that's what it is here. 12 times 3x over 4 minus 12 times 6 equal to 12 times x over 3 minus 12 times 1. So we just took each term and multiplied it by 12. Whether it had a denominator or not, you have to multiply each term in order to keep your equivalency. Next step is to simplify. All right, so 4 divides into 12 and leaves us with 3. 3 divides into 12 and leaves us with 4. So 3 times 3x is 9x. 12 times 6 is 72. 4 times x is 4x. And then 12 times 1 is 12. So now we have a regular equation without fractions. All right, so now we can solve. We cleared out our fractions. We go ahead and solve. We have x terms on two different places, so we need to, with two different sides of our equation. So we need to, just like before, get our terms with x on one side, terms without x to the other side. So we can subtract 4x on both sides. 4x on the right cancels. 9x minus 4x is x. Minus 72 equal to negative 12. Now add 72 to both sides. That'll leave you with 5x on the left and 60 on the right. Then we can finish off the problem by dividing both sides by 5. And x is equal to 12. All right, so looking at this next one, we have 2x minus 3 over 3. So the quantity, the whole quantity of 2x minus 3 is over 3, plus 1 over 2 equal to 5 over 6. All right, so we need an LCD, and we're looking at the denominators of 3, 2, and 6. So we want the smallest number that 3, 2, and 6 get divided into evenly, and that will be 6 for us. 3 can divide into 6, 2 can divide into 6, and 6 can divide into itself. So that's the smallest number. I don't think I mentioned this initially. Um, let's say if you saw 12, you didn't see 6. As long as each one of those denominators can divide into it evenly, you'll still be okay. Even if you didn't find the smallest common denominator, you could use 12, like I said, 24, something that all three can divide into. It's just that at the end, you will most definitely have to reduce. Using the least common denominator will prevent having to reduce if possible, but you will most definitely have to reduce at the end if you use something larger than the least common denominator. So as long as whatever number you're choosing is a number that all your denominators can divide into evenly, you'll still be okay. All right, so let's multiply that least common denominator, that 6, to each numerator. That allows for the 3 to cancel into the 6 and leave you with 2. 2 cancels into 6 and leaves you with 3. 6 cancels into the 6 and leaves you with 1. So before I distribute it, I just wrote this just to make sure we were okay with what was left. So we have 2 times 2x minus 3, 3 times 1, and then there's 1 times 5. We want to distribute that too. And that leaves us with 4x minus 6 plus 3 equal to 5. So on your left side, we got negative 6 and positive 3. Combine those like terms and that'll leave you with negative 3. So now we have 4x minus 3 equal to 5. So we have 4x minus 3 equal to 5. Add 3 to both sides of the equation. That leaves you with 4x equal to 8. Finish it off by divided by 4. And x is equal to 2. Any questions? Any questions? This right here is someone that just asked me about reducing fractions, and your final answer. I was just saying that if you had 8 over 4, you are expected to reduce it to 2. 9 over 4 is fine, but if you have 14 over 4, you can still reduce that because 14 is 2 times 7, 4 is 2 times 2, the 2's can cancel, and leave you with 7 over 2. So I mentioned that before, but we have revisited that here. So that's all that this is. just make sure we were re-emphasizing the fact that your answer is expected to be in reduced terms, the most simplified terms possible, or lowest terms. All right. So the next thing we talk about in this section is to solve for a specified variable. So when you solve for specified variables, you may or may not come up with well, more than likely, you will not have a solid answer. So what I mean by that is, like, in other words, got the wrong button. So in other words, x equal to 9 over 4. You will more than likely not have that type of answer, or x equal to 2. You will have x equal to an expression. So in other words, looking here, we have p equal to 2l plus 2w. If we want to solve this for L, that's great, but we're going to have two variables that aren't given an account for. So those are going to be on the other side of your equation, and you will not be able to add them or subtract them from each other because they're not like terms. So the way we will solve this is in the same fashion that we would solve solve it with numbers. These variables represent numbers. They are unknown numbers, but they represent numbers, so we treat them the same way. So if I had, and that's where this, I keep doing that. That's where this came into play. If I had 5 equal to 2L plus 7 and I wanted to solve for L, then I would subtract 7 from both sides first. So here I have P equal to 2L plus 2W. I want to solve for L, so I'm going to subtract 2W from both sides. Now once again, W and P are not like terms, so I cannot subtract them from each other. So that'll leave me with P minus 2W equal to 2L. All right, and then to finish it off, you divide by 2 because you want to get 2 off of L. And your answer is P minus 2W over 2. All right. So before I go any further to explain what you can or cannot do going forward, any questions? All right. So as far as reducing further, notice I said this was the answer. You can reduce further, but you wouldn't have to, and I'll explain why you wouldn't have to in a few minutes. But what you cannot do is come down here. I can do this blue. Come down here and do P minus 2W over 2 and just cancel out the 2's and have P minus W. So this is incorrect. You can't cancel out that way. So if you want to cancel this out and keep going or go further, you would do P minus 2W over 2. This 2 has to go into each term. It can't just cancel out into 1 and then not have any effect on the P. It has to go into each term. So when you go to the next step, what do you mean like that? You have P over 2 minus 2W over 2. And so the 2's can cancel now that involve the W, but that 2 that's under the P has to still be there. So P over 2 minus W is the same thing as P minus 2W over 2. So these two, either one of these answers are fine. but just don't cancel out the 2 and not let it affect the p as well. So everything that's in that numerator has to be affected by the division of 2. All right. So now because the 2 couldn't cancel out into the p, this answer is fine. When you would have to reduce is if you had this type of expression. If you had 4p minus 2w over 2. Now because this 2 can go into this 2 and the 4, you are expected to go further. So once again, this is just an abstract example. This has nothing to do with the problem we just done. The problem we just did not have a 4 in it. So I'm just saying if you had a 4 sitting in front of p, you most definitely would have to reduce further. The 2 can go into both terms. So you break it up, 4p over 2 minus 2w over 2. 4 divided by 2 is 2p. 2 divided by 2 cancels out, leaves you with 1. So that would just be minus w. So that's the difference between when you have to reduce this type of expression and when you do not. That bottom number has to be able to go into each term if you do have to reduce or if you are expected to reduce. Questions? Any questions? All right. 1 or 2 more examples and then we'll be done for the day. So 5a minus 3b, and this one is similar to the last one that we did. We want to solve 5a minus 3b equal to 7 for a. First thing we do is get all the terms without a onto the other side. So we'll add 3b. 3b and negative 3b will cancel. So you have 5a equal to 3b plus 7. Or you could have said 7 plus 3b. Either order is fine. Divide by 5. And your answer is 3b plus 7 over 5. Any questions on that before we look at it? I believe it's the last one. All right. So let's look at this last one for the day. Trying to erase this stuff so I won't have to break. All right. So we have I equal to E over capital R plus lowercase r. We want to solve for capital R. So keep in mind, capital R and lowercase r are not the same variable. They're not the same thing. So you cannot add them together and get 2R. So capital R and lowercase r are separate from each other. So I need access to capital R. I do not have access to capital R yet. It is in the denominator. I need to get it out of the denominator. So I need to multiply both sides by that quantity that's in the denominator. So multiply both sides by capital R plus lowercase r. On the right, they will cancel, leave me with just E. And on the left, I have I times the quantity of R plus R. All right. Still need access to R. I don't have that yet because of the parentheses, so I'll distribute. So now I have I times capital R plus I times lowercase r equal to E. Goal is still to get capital R by itself, so I will subtract I lowercase r from both sides. Now I have I capital R equal to E minus I lowercase r. So to finish it off, I will divide by capital I. Capital I cancels on the left side. Right side, we have E minus I lowercase r over I. All right. Questions? Any questions, concerns, comments before we look to let out today? So you guys finishing up, that is 9.1. So your test and test review is already up for chapter 7. Make sure that once you get to chapter 7's test, give me a copy or shoot me a copy of your scratch work for your test submission. Once again, you do not have to do that for your homework, but for your test. We're looking to do that. Also, next week, I'm going to set aside one day to just review. I won't do anything new. My other class chose Thursday, their Tuesday, Thursday class. So would you guys want Wednesday or Friday? Does it matter? Anybody prefer Wednesday versus Friday? Talking about for review. You can ask whatever questions you want. I will not do anything new on that day. I'm thinking probably Wednesday, probably be the better day. And then as far as Friday, that'll give us another day if we had any questions. So that's just my thoughts. You have the weekend to generate questions. You go through chapter 7 or even chapter 9 if you already done chapter 7, and see what kind of questions you have. And then Wednesday would basically be a review day for chapter 7's works. And that way, if we have more questions, we can do those on Fridays as well, on Friday as well. So, no objections, no objections. I don't see anybody responding to anything. So I'm assuming that's okay. That's all right. So that being said, it's 8:47. Try the stuff out, see if you get stuck. You can always email me if you have any questions. And you don't want to wait until Monday. But if Monday hit and you have some questions, I'll most definitely answer them before I get into anything new. So outside of that, you guys have a great weekend. Be safe. And I will see you on Monday.